What exactly is the nature of force? Unfortunately, mankind has not fully understood it so far. There are four types of forces known to mankind: gravitational, strong, weak, and electromagnetic. Humanity's understanding of gravity is the earliest and the first force with a clear formula. However, it is also the most difficult to understand. At the microscopic level, gravity is the weakest of the four basic forces. But in the macroscopic world, it is extremely powerful, so big that it can crush a star, tear a neutron star to pieces, and even light can't escape the boundaries it draws. When the mass of a star reaches a certain level, and the fusion reaction is not enough to resist the gravitational force generated by its own mass, it will be gravitationally compressed into a neutron star or even a black hole. For gravity, Einstein has given a hypothesis. It is not real, but the mass bends the space-time. The light is bound by the gravity of the black hole. It is not the gravity that makes the light change the direction of propagation, but the mass of the black hole distorts the space where the light propagates. And standing in the light's point of view, it still walks in a straight line. The strong and weak forces seem to be much simpler compared to gravity. Both of them act over small distances and are short-range forces. The strong force only works at the atomic nucleus scale. It allows protons and neutrons inside the nucleus to bind together tightly and pass through gluons. The whole process is very complicated. The weak force has an even smaller range, 3 orders of magnitude smaller than the strong force, which is transmitted by W-wave leptons and Z-wave leptons, and mainly acts on electrons, neutrinos, a class of leptons, and the decay of a neutron into a proton is the result of the action of the weak mutual force. These two forces are not much mastered by mankind at present, and there is no manifestation of them on the macroscopic level. The above is the consensus of physics, and there are applications, although it does not mean that this is the ultimate theorem, just as in the Tang Dynasty we learned to make gunpowder, but have not yet touched the essence of redox. Lastly, let's introduce the electromagnetic force, which seems to be the twin brother of the gravitational force, which is like it everywhere. Scientists have also been trying to find a unified theory to unify gravity and electromagnetism, and one of the most famous attempts at a unified theory in modern physics is string theory. However, string theory has its problems. In order to explain the ever-emerging problems, it has had to introduce the concept of higher dimensional space, which, together with the various solving string models, requires many complex mathematical models to provide theoretical support. In short, string theory is slowly becoming a metaphysics. How can it be so complicated when the path is so simple? What are the forces involved? Maybe we can never touch it. It should be the ultimate nature of the universe.